Hello, everyone. Let's get started. Okay, so this is where we kind of left things off. So we said if something goes wrong, let's kind of maybe just go one previous slide. So there are two critical phases of installing or instantiating a new view, which is first you detect the failure and you do a view change. And the first thing we do as part of the view change, we need to essentially, first of all, synchronize, make sure enough people have detected failure. And we also need to synchronize who the next primary is going to be, who the next leader is going to be. And so that's sort of the first phase is the view synchronization. And then the second phase is to construct a new view. And this new view is to essentially do state synchronization. Or in other words, this new view will entail all the committable transactions. So this new view be a sort of a large message that says what are the all potentially committable transaction that needs to be preserved. And so once a new view are agreed upon, then that large message is sent and everybody were able to bring themselves up to date, and also to ensure that no committable transactions are omitted. So basically, if there were enough replica who had prepared a request in a previous by the previous leader in a particular round, this new view should make sure that those requests that were prepared by enough or by the majority are preserved. So those are the two key things. One is the view synchronization, one is the state synchronization. The view synchronization tells us who the next view is, so we can agree upon who the next leader is. And the state synchronization is to ensure preservation of any committable transaction. Questions? Why is it important to have a view synchronization? I mean, of course, we've been talking about the preservation of committable transaction. We know that's important because if you promise the client that the transaction is committed, and so if once we make a commitment promise, we want to make sure that we can remember that decision and honor that decision in future. So that part is somewhat trivial based on all the conversation we had so far. But why is it important, or why do you think it's necessary to also do a view synchronization? Questions on what view synchronization is? That clear what the intention of it is? Yes, no, yes. Okay, well, what's your understanding so far? Mm-hmm. It's related to consensus, yes. What's consensus? Okay, so you get agreement on everything that goes into our ledger or into our log. There needs to be consensus moving to v+1. And so when we detect a failure, we want to change primary, we need to have some form of an agreement. Why do we need to have an agreement when we move? Well, we need to agree to make sure if I'm expecting he's the primary and you're expecting that she's the primary, and if he proposes something, well, do you vote for her or do you vote for him? You have to decide who are you going to vote for. So if there are multiple primary at the same time, or there's multiple replica thinking that they're primary, then none of them will be able to collect a core. So it's important that we always have one leader that the majority agrees upon. And so that becomes the view synchronization. So before we can even start the new view, we need to have a sufficient agreement who's going to be the next primary, who's going to be the next leader. So that's the view synchronization. Is to kind of agree upon, initially was me, and you all kind of detected failure, and you need to agree who the next person is going to be. And you need to move with synchrony, because if you all agree that he's the next primary, but he doesn't do his job, then you all want to kind of move to the next person, then to the next person. And we don't want to be in a situation that different replica move at different speed, and so they get timeout at different speed. And we end up in a situation that everybody thinks somebody else is the leader. And the moment we get into that sort of dispersion, then no one could successfully commit anything, because no leader who proposes something will ever collect enough votes. And so it'd be complete disarray, and everything will stall. So it's important, as we change our view, we make sure that there is agreement on who the next leader is. And once there's an agreement on the next leader is, and then the next leader will tell us what has been, or what could have been committed by the in the previous views, and he needs to construct a proof for that. And if that proof is valid, every replica will validate it, and they accept it. And so now officially, this new replica is the new leader, and it can now propose new transaction. So that's sort of the high level. Yes. We'll get to that. We'll get to that. So basically, the moment, I mean, the basic answer is that when you raise your flag saying we want to change the leader, you kind of include your history of everything you've done. And the person that becomes or is the next in line to be the leader collects everyone's history. And based on everyone's history, it proposes what was done before. And then it will give the proof, or it just simply pass on everybody's history. And now everybody could validate whether the primary came to the right conclusion of what needs to be preserved or not. And if the primary decision was incorrect, nobody will vote for it. Nobody will accept this new view. But if the primary proposed view is reasonable, makes sense, it's not dropping anything that shouldn't be there, that should have been there, then things will move forward. Yes? No? Okay. All right. I'll just kind of move on. I'll come back to it. I don't see enough satisfaction in anybody's face, so I'll come back to it. But let's kind of let it sink in a little bit. So at some point, let's say the top line is the current primary, and somehow at this point, everyone able to detect failure. And they all kind of say a failure was detected, and they all agree, again, just somehow they all agree this V+1 is the next leader. They all send their view change message to this new leader. And inside their view change message, they kind of include their history. They said they include whatever they prepared, let's say. They could also include whatever they committed, but what they prepared is sufficient. And at that point, this new primary will collect enough view change message. So now, the moment it collects enough view change message, that means now it's an eligible primary. It has collected enough votes. A quorum, 12+1, have voted for the primary. And it also have collected enough view change message of the history of all the prepared stuff or all the committed stuff. And so based on that, it proposed a new view. It says, let's all start a new view, the new view plus one. And inside this new view, it also includes all the messages that were either committed or they were committable, meaning that there is enough support that they could have potentially been committed. And after that point, every replica will update their state, the one who received this new view message, and things will progress. And so the new view or the new primary can begin to now make new proposal. So a failure was detected, and everybody told the primary, the next primary, endorsing it as part of the view change. It also shared their history of what they've prepared so far. The new primary collects those, sends out the new view with the proof of what was done. And then everybody whoever receives it, they update. And now they say, okay, they officially that because now they've received a valid new view from the new primary. So those are the steps. So let's now pause again. And so questions. No, it's not necessarily linear. I mean, there are linear number of lines, but each of these could be n in size. So it could be, so this is quadratic because, for example, if you had prepared something and you could say that proof of you have prepared, and so you could kind of pass on all the endorsement from all the prepared messages you've gathered from everyone, and so that's size n, and so that becomes your certificate of the prepared. And now, so even if only one thing was done, potentially only one thing was done in a previous view, in my view change message, I said I prepared transaction T, I provide my proof for it, size n, they all do the same thing. So these are n messages, each of size n. So that's n squared complexity, quadratic complexity. And in the same way, when the new leader proposes what was done previously, then it needs to provide the proof. So it has to say, well, is because of this prepared, something was prepared, and this prepared is valid because of its certificate. So again, each of these messages that it sends out, it could have size n. Or even larger. So again, it will be quadratic again as well too. Yes. Louder. Oh, that's the number of non-faulty replica. Non-faulty, just a symbol. Number of total number minus the faulty one. So 12 plus 1, for example. Any other questions? So at what point we're getting state synchronization? At what point do we get preservation in this picture? Here, here, here. And this time, when does R3 know about state synchronization? When is R3 state is synchronized? Once it receives the new view. So now, how is this related to what we had been talking about in terms of commitment that ensures once something is committed, it will be preserved? Because we kept talking about this view change ensures preservation. So where does that come into the play? So why is it if something was committed, it will show up at this blue point if something was committed. Well, no, if nobody got the commit, so be precise. So how does the primary guarantee to get those messages? Who's gonna send those messages? So how does it that a commitment decision may be either replica being malicious or the new primary is malicious? Is there any way to bypass it or drop it? Or why is it that there's no way to exclude something that was committable? And I stress the point committable. Committable means that even though maybe enough replica had prepared it, no one may have observed the commit decision. So that means committable. Something that could have been committed, even though no one observed its commitment, neither the client nor any replica. So that could be committable. A committed transaction is something that was committable and also observable, or it was observed. So one is observable, one is observed. A committable is observable, meaning there is enough support that should be committed. Committed means it's observed. Somebody observed the commitment. Somebody collected enough commit messages and concluded that message was committed. Is the distinction clear? Anybody, a replica, doesn't matter who. Anybody can be. Anything that is committable, that means is observable, meaning enough people have prepared it, so is committable. Committed means somebody observed it. Now, whether client replica doesn't really matter. Somebody observed it. But you can only observe a committed decision of a committable transaction, something that could have been committed. So why is this preserved? Why the commitment phase brings preservation into this figure? Folks in the back, thoughts? Why do you think it preserves it? What ingredient or what mechanism in this ensures anything that was committed cannot be excluded? Well, uniqueness is a different property from preservation. Is it clear what goes inside the view change message? The messages I put in my prepare, what do you put in your prepare message? What in your view change message? What would you put in your view change message? All the transaction. Let's say there was only one round. So far, only one round down. If you had prepared a transaction for that round, you include it. If you have committed it, you would also include it. You would also say I've committed it. But the important thing is something you prepared. So that's what goes in a view change message that each replica sends. Now, why is that sufficient to ensure that a committable transaction is not excluded and it's preserved? So even if some replicas who are participating in this recovery are malicious, or even if the new leader is malicious, we can continue to ensure and guarantee that it's not excluded. A committable transaction.
this is like single node states that the message was committed, it knows that the majority of the targets on that majority of nodes have targets, so even if it's one of them, there is moved from the 2F plus one that is on that same message, so that it wasn't prepared by the majority of the other nodes.
Okay, so breaking that into smaller pieces, so this is how many of those view change messages will have a prepared request, a prepared vote, given something, let's say, was just committed. Let's just forget about this committable business. If something was committed, how many of these view change messages will have a prepared vote for that transaction? 12 plus 1? Why 12 plus 1? That's every node exit. What if somebody lied when you were forming the committable quorum? When they still said it preferred? Yeah.
Or they lied.
Well, 12 plus 1, not all of them were honest. Some of them will not share it. Hmm?
They cannot reach a prepared state.
Reach a prepared state, you're malicious. You say you vote for it. I get committed. I use your vote. You said you told me you prepared. I get committed. And now is the new leader, and he asks who was prepared. We're gonna say I resign. So he's not gonna get your vote. So how many of these view change messages are guaranteed to have okay? So because you said we have, let's go to our glorious diagram. I haven't drawn this for a few days. I'll come back to you. Give me a sec. Okay. All right. So our prepare core, what could have it? What could we have in our when we were doing committing transactions? So we're trying to. So this is our prepare core, so let's say for transaction T. So how many replica would we need in this? Okay, so now let's look at the composition of it. What could be in this? So, okay, so we have F bad nodes in there. What else? And then we have F plus 1. Good. And what else do we have? Maybe they got T2. This is for T1. Maybe there are some good nodes that either never saw T1 or they maybe have got something else. They don't know. In general, we say there are maybe F nodes that are potentially gone. Okay. So given this, how many of these view messages that are potentially sent are we going to say we have T1? F plus 1. Yeah, something in the back? Okay. How many messages does this new primary needs in order to construct a new view? How many messages does it need to receive? What's that? 12 plus 1. So let's call that a view change form. Okay. For primary v plus 1, let's say. It has to get a view change messages referenced him or her, whatever pronoun is for replica or it. So what could go in there? Some of the stuff that could be in that circle. Could these guys be in it? Okay. What are they gonna say? They're gonna say, let's say, nothing happened. Could these guys be in it? Oh, but they're all, well, they're all none of them have got anything so far. I mean, they all said, we assume that everybody detected a failure. So now they're all trying to do a view change. So they're all gonna say, and let's kind of simplify, actually we already did the simplification. They're all gonna say, nothing happened. What else? Do we have a view change quorum now? Not yet. What do we need? So we need one person. And this good one is gonna be this set. And it's gonna say T1. So how many of these view change messages are guaranteed to have a prepared vote? Just one. They could have constructed a case that it could have been another form. There could have been another form. It's not that this is the only possible one. There could have been another form in which we have F plus 1, GT1, and also FG who said, we don't know anything happened. It could have also, that's also a possible form. And it could have been that everybody was non-faulty and 2F plus 1 unanimously say, or 3 plus 1, 3F plus 1 unanimously said that something happened. All of those are possible. But this is, if everything goes wrong, these two will be included. If everything goes wrong, this is the worst case scenario. And in the worst case scenario, we will have one vote who will say, and make sure that is preserved. And this becomes the proof of saying that, well, we should preserve T1 because this is the quorum of the messages I get and I need only a quorum. And so this is a valid quorum. These guys said nothing happened. This node said something happened and it does actually have a proof that something happened. It can prove to us that in fact something was prepared. So then I use this as my evidence as the primary. And I say that in round 1, T1 should have been prepared. But we should prepare T1 in round 1.
Two questions. So when we speak about that one good one, basically it has received 2 out of 1 many messages, right? 2 F plus 1
Prepared.
2 F plus 1 prepared.
Yeah.
So
No. It has received, yes, 12 plus 1 prepared messages. Yes.
yes. And
Prepared messages, not prepared.
yeah. Oh, I saw it because we're not.
Yeah, because, and assume those messages that it received, they're all digitally signed, so it has a proof. And says, even if these notes says, oh, we never said anything, there is a message with their signature saying that they did.
So only way to get this like through that's something that's prepared, something has to be prepared, right? So the vice versa can happen, where, let's say, um, let's say two nodes say that something wasn't prepared, but then one node says that one was prepared. There's no such thing as proof for nothing, right? There's only.
Yeah, it might be that nobody had seen anything. Or for example, if let's say you were the only one that were prepared. So it wasn't committed, you were the only one prepared, and they formed this circle, and you're not in it. And this circle says nothing happened. So, and then the new primary says nothing happened, there is a proof. The quorum says nothing happened, even though you prepared, doesn't matter. They ignore you. So that was the reason, in order to make sure that something is committed, you gotta make sure you're not the only one who got prepared. You gotta make sure there's enough people who get to the prepared state. And so once we form this, at least one of you will raise the flag, says, no, wait a minute, something didn't happen. So it's possible that it would also be the case that you were the only one who prepared. We do the view change, and by luck, you're included in this, and we will preserve it. So it also goes the other way. Doesn't mean that it had to be committed. As long as somebody's in this circle saying that was prepared and has a proof, we'll take it. But if something was committed, then we guarantee that there is at least one person with proof in this circle. So that's the only sort of assertion or proposition. If something was committed, then we guaranteed, as shown in this example, that one person will be prepared and included in that quorum, and that one person, minimum one person, and that one person will choice percent.
So what do you need a view change on? Can't you just ask every single like whether or not they have a proof? Because if they have a proof, then that suffices them. You need to just ask every single.
Well, every single replica, first of all, is essentially telling you that. But there's two difficulties. One is what?
Oh, so I guess it's just like the worst case then.
No. First of all, some people may not respond to you. Okay. So if people won't even respond to you. And maybe some people do respond to you. But for example, let's say you ask everybody around and you get these 12 people tell you nothing happened. What do?
You the waiting for one.
So you're still waiting for quorum then?
Yeah, I think it's because it's like the worst case. It's like if you have
So the way you have to think about it, it's not so much the worst case. Sure, you could ask around and one person, the moment you have a proof, then all things are easy. The difficulty is when you don't have a proof. Then you have to prove, then you potentially have to prove a null certificate saying that I asked enough people and enough people said no. And that becomes your proof. So you either form a null certificate or you show a single proof that somebody prepared. But you cannot call it a day until you've either seen a proof or you've seen a null certificate. But yeah, you could by one vote, by a single view change message, essentially have a proof for the new view. There's another intricacy to it, but as far as to prove that this is a valid thing that needs to be preserved, that's good. You only need one view change message. The intricacy comes around. You also need to collect, even if in this scenario, it wouldn't have been sufficient wouldn't be enough to just show this, even though this is a valid proof. You also needed to show this, not because they add anything to the preservation, but they're voting that you're the next primary. This is 12 plus 1 for you as a vote that you are the next primary. If you just collude with somebody, for example, you were supposed to be the primary, and I collude with him, I give my prepared message, and he jumps ahead of you and says, oh, I'm the primary, and this is a proof. And he can bypass a lot of primary one. So you still need to show a quorum saying that you're the primary, and that goes back to the view synchronization. So that makes sure that you don't somebody out of the line not gonna say, oh, let's just bypass a whole bunch of nodes.
For the right side circle, so if you can reach that case, the view change fell.
This is the view change. This is the view change messages, and this is what the primary is forming. So what's your question?
As this case,
This is a valid quorum.
this bot,
This is a valid quorum.
even there is no like there are only one,
Yeah, because that one has a proof.
so
These ones, they just say nothing happened. They can't really prove nothing happened.
the rest of them is to listen to the one that's a proof.
This set as a whole becomes the proof. Because this thing it says that, well, here is a proof that something was prepared. These guys say, well, we don't know anything. And so it's not conflicting with it. If they had potentially said, we did T2, and they could have somehow shown a proof for it, then this would have been problematic. But we did say that the prepare phase ensures uniqueness. So they wouldn't be able to show you a proof. The best they can do is to say nothing happened. And that now the uniqueness that was mentioned, that's where the uniqueness comes in. Question. Yes.
Say the band says something, if the band notes vote for something else there.
They can't prove it. I mean, they can say whatever they want, but they cannot prove it. It's in just it's a random noise.
So as long as you cannot prove it, you need to listen to the one.
Yeah, you would only take the one. The only information you really extract from these is that they vouch that you're the next leader.
Is this forum unique? Like one that says leader in you, the recovery is necessarily unique. And he chooses the best form.
Yeah, it's not unique. Why is it not unique? Because what would happen the case that nothing was committed? So going back to that case, he's the only one who prepared. You're the new primary. You could form a valid form that includes him, or you could also form a valid form that excludes him. So there are two possible forms. So it's not unique. So that's why the primary needs to choose one supporting. Because if something was committed, then it guarantees that any core we construct will have one person with a prepared request. But if this request wasn't committed, then again, maybe only he's the only one who were prepared. You could construct a form that includes him, or you could construct a form that doesn't include him. Both of them are bad.
How is it decided?
The primary decides it.
What is the
Well form means that it's 12 plus 1. The size is well formed, and then there's no conflicting stuff in it. So everybody says nothing happened. You construct a form, everybody says nothing happened. That's valid. You also construct a form, everybody said nothing happened. One person says, no, wait a minute, I did prepare something. That's also valid. But if you construct a form that some people says X, some people says Y, then something is wrong. But this is different. They just said nothing happened. We're not aware of it. We don't know anything. They never got to the prepare state. This was the only one who got to prepare state, and that's okay. So that's why the role of the primary is important here, because essentially the primary chooses, proposes what was done before, which has to provide that. So this view change is almost like another commitment. It proposes it, but in the regular commitment, it could have proposed anything. But here, when it proposes something, it needs to have some form of a backing. But it needs to go, this proposal, this is in fact not the end of it. This is essentially a new view. Everybody needs to prepare it. Everybody then needs to commit it. And only then it guarantees that the new view established. So this is a premature ending of the new view. Because at this point, there's no guarantee that everybody getting the same thing. The primary could be malicious and send in a different new view. It could have sent one new view that didn't include him, and it could send another new view that did include him. So these new view messages could itself be conflicting. They're valid, but they're not but could be conflicting. So that's why they need to be prepared and committed. So essentially, we need all phases of consensus here. We need to prepare and commit as well. So the new view is somewhat proposed or pre-prepared. Then we will have a prepared. Then we will have a commit.
But then we discussed preservation and batch working.
Preservation, because all of those forms are valid form. So any of these form you chose, any valid form that you chose, any valid form will have the preservation property satisfied. But uniqueness begin to, we're going to start losing the uniqueness is the case when nothing was committed. So, and if nothing was committed and only maybe was prepared by one, it's valid to keep it, and it's also valid to drop it. So valid, the preservation has not been violated. So it's possible to have two different form recovery forms when things are not settled fully, because nothing was committed. Some people, he's the only one who got prepared. So it's possible to form a quorum that excludes him. It's also possible to form a quorum that includes him. Both of them are valid. And both of them satisfy the preservation property. So you need these extra phases, the prepare and commit. Think of this as proposal and then prepare and commit to ensure that the primary didn't lie, did not equivocate, giving different new view to different people. So essentially becomes identical to commitment. Question? I thought I saw another hand.
Basically, all of it happens in plus when kind of what the primary, the new primary side, a vision state based on what I received from the UK. And all the state synchronization is the EU, and so that where what
Yeah, so this essentially tells you what was done, tells you the history, propose the history, and then you make sure it's unique, and then you preserve it. So at this point, if the primary is done well, this message, this new view message, has the history. So it preserves the history, conditioned upon what this proposal is unique, and enough people observe its uniqueness, and then everything that was proposed previously or committed previously will be preserved. But the most important part is this. How do we get to detection? So I would say that's the trickiest part. Because this is essentially was just commitment. This is identical. Propose, prepare, commit. exactly as the commitment. It's just the seed is different. In the normal commitment, you get the proposal, you get the request from the client. In the view change, you get the proposal from the replica saying what was proposed earlier. But the steps are the same. Propose, prepare, and then commit. So this part becomes the view synchronization. Now that becomes the more subtle, intricate aspect.